Hello everyone. In previous class, we discussed about what is the SRM, means switched reluctance motor, its working principle, construction, advantages and disadvantages, and the application of switched reluctance motor. पिछले वाली क्लास में हमने देखा है SRM के बारे में पूरा स्टडी किया था. So now in this lecture we will study about what is repulsion motor. आज के लेक्चर में हम देखेंगे repulsion motor क्या होती है, introduction of repulsion motor, its construction and working principle. Next is the classification or types of repulsion motor. Next topic is the advantages and disadvantages and some application of repulsion motor in a different fields. And finally the references of this presentation. So in this lecture we cover all these topics one by one. So let's start with topic 1, introduction of repulsion motor. So what is the motor? Motor is a rotating electrical device, or machine is called motor if it is convert electrical energy into mechanical energy. So a motor is an electrical device that converts electrical input into mechanical output, where the electrical input can be in current or voltage form and the mechanical output can be in torque or force form. Motor consists of two main parts, namely stator and rotor, where the stator is a stationary part of the motor and the rotor is a rotating or movable part of the motor. The motor that works on the principle of repulsion is known as repulsion motor, where the repulsion takes place between two magnetic fields or either stator or a rotor. Repulsion motor is a single phase motor. The next topic is the construction and working principle of repulsion motor. So the construction, it is a single phase AC motor which consists of a pole core, that is the north pole and south pole of a magnet. The construction of this motor is similar to the split phase induction motor and DC series motor. The rotor and the stator are two main components of the motors which are inductively coupled. The field winding or a distributed type winding or the stator winding is similar to the main winding of the split phase induction motor. Hence, the flux is evenly distributed and the gap between the stator and rotor is decreased and the reluctance is also decreased because the reluctance is directly proportional to the length of area between stator and rotor, which is termed improve the power factor. The rotor or armature is similar to the DC series motor, which is provided with a drum type winding connected to the commutator, and where the commutator is in turn connected to carbon brushes which are short circuited. Hence, the flux is evenly distributed and the gap between the stator and rotor is decreased, and the reluctance is also decreased, which is turn improve the power factor. So this is the constructional diagram of repulsion motor. It consists of stator, rotor, commutator and carbon brushes. The rotor or armature is similar to the DC series motor, which is provided with a drum type winding connected to the commutator, where the commutator in turns connected to carbon brush which are short circuited. So in a figure, next is the working principle of repulsion motor. Repulsion motor work on the principle of repulsion, where two poles of a magnet repel. The working principle of repulsion motor can be explained from three cases of alpha, depending on the position of the magnet as follows. So case 1, where alpha is equal to 90 degree. Assume brush C and D are aligned vertically at 90 degree and the rotor aligned horizontally along the D axis or field axis, which is the direction of current flow. From the principle of Lenz's law, we know that the EMF induced mainly depends on the stator flux and the current direction, which is based on the alignment of brushes. Therefore, the net EMF of brush from C to D is 0, as shown in a figure, which is represented as cross and dot. There is no current flow in the rotor, so the value of IR rotor current is equal to 0. When no current passed in the rotor, then it acts as an open circuit transformer. Therefore, stator current IS is less. Case 2, when alpha is equal to 0 degree. Now the brushes C and D are oriented along the D axis and are short circuited. Figure में देख पा रहे हैं हम. Therefore, the net EMF induced in the motor is very high, which generates the flux between windings. The net EMF can be represented as cross and dot as shown in a figure. जो हमारा नेट EMF इंड्यूस होगा वो क्रॉस, ये क्रॉस बना हुआ है और इन डॉट से रिप्रेजेंट किया हुआ है. It is similar to a short circuit transformer, where the stator current and the mutual induction are maximum, which means rotor current is equal to stator current is equal to maximum value. From the figure, we can observe that the stator and rotor fields are 180-degree opposite in phase, which means the torque generated will oppose each other, so the rotor cannot rotate. Case 3, when alpha is equal to 45 degree. So this is the diagram when alpha is equal to 45 degree. When the brushes C and D are inclined at some angle, for example 45 degree, and the brushes are shorted, let us assume the rotor brush axis is fixed and the stator is rotating. So this is the diagram. The stator winding is represented as Ns, numbers of effective turns, and the current passing is Is. The field produced by stator is in the direction Is into Ns, which is the stator MMF as shown in a figure. The MMF, magnetomotive force, is resolved into two components, MMF1 and MMF2, where the MMF1 is along with the brush direction Is into NF, and MMF2 is perpendicular to the brush direction, means Is into NT, which is the transformer direction, and alpha is the angle between the Is NT and Is NF. Hence, the flux produced by this field into two components is Is into NF and Is into NT. So the EMF induced in the rotor produced flux along the Q axis. The field produced by the rotor along the brush axis is mathematically represented as follows. Is into Nt is equal to Is into Ns into cos alpha, equation 1. So the Nt is equal to Ns into cos alpha, this is equation number 2. And Nf is equal to Ns into sin alpha, this is equation number 3. Since the magnetic axis T and the brush axis coincide with the rotor MMF, which is along the brush axis, is equal to the flux generated by the stator. So, construction as well as the working principle of the repulsion motor. In short, the repulsion motor work on the principle of repulsion. The next topic is the types of repulsion motor. The repulsion motors are classified into three categories. First one is compensated type repulsion motor. Second one is repulsion start induction type motor and repulsion type motor. So the first one is compensated types repulsion motor. This is the diagram for compensated type repulsion motor. This motor consists of main field winding and compensated winding. It consists of additional winding, namely compensating windings, and An additional pair of brushes are placed between the short-circuited brushes. Both compensating bindings and a pair of brushes are connected in series for improving the power and the speed. Means power factor और speed को improve करने के लिए compensating binding और pair of brush को series में connect करते हैं. A compensated type motor is used where there is required for high power at the same speed. जहाँ पे हाई पावर की जरूरत होती है हमें सेम स्पीड में, उस जगह पे हम कंपनसेटेड टाइप रिपल्शन मोटर का यूज करते हैं. Next one is a repulsion start induction type. So it starts with the repulsion of the coils and runs with the induction principle, where speed is maintained constant. तो ये जो रिपल्शन मोटर होती है, रिपल्शन स्टार्ट इंडक्शन टाइप, ये स्टार्ट तो रिपल्शन प्रिंसिपल के थ्रू होती है और रन करती है इंडक्शन प्रिंसिपल पर. It has a single stator and rotor similar to DC armature and a commutator where a centrifugal mechanism short circuits the commutator bar and has higher torque, means 6 times than the current in the load. The operation of repulsion can be understood from the graph. That is, when the frequency of synchronous speed is increased, the percentage of full torque load start decreasing, where at a point the magnet poles experience a repulsive force and switches into induction mode. Here we can observe that the load is inversely proportional to the speed. So this is the graph for repulsion start induction motor. The next topic is advantages, disadvantages and the application of repulsion motor. First one is advantages of repulsion motor. So the advantages are it has high value of starting torque. The speed is not limited for repulsion motor. Next one is by adjusting the value of alpha, we can adjust the torque where we can increase the speed based on the adjustment of torque. By adjusting the position brushes, we can control the torque and speed easily. So these are some advantages of the repulsion motor. The disadvantages are the repulsion motor has speed varies with variation in the load. The power factor is less except for high speed. The cost of the repulsion motor is high and it is also require high maintenance. So these are some drawbacks of the repulsion motor. Next one is some application of repulsion motor in different fields or areas. They are used where there is a need for starting torque with high speed equipments. Coil winders where we can adjust speed flexibly and easily, and the direction can also be changed by reversing the brush axis direction. It is also used in twist or lift. So these are some application of the repulsion motor. The next topic is the references of this presentation. So these are the references. Electrical Technology by B.L. Thareja and A.K. Thareja. ElectricalEasy.com. Electrical for You. Circuit Globe. Alprofus.com. Thank you for watching this video.